Hey everybody, Mr. Rubo here. Today we are talking performing function operations. So we have four basic operations, I should say: addition, subtraction, multiplication, and division. Right. So we know how to do that with numbers. Well, we can also do that with functions. So if we see f plus g of x, this is function notation, and it is telling us just to add the two functions together. Okay. So just for sake of example, we're going to say f of x equals 2x plus 1, and this will be true for all of the ones we do today, and g of x equals, let's say, nice simple quadratic x squared. So f plus g of x would equal 2x plus 1 plus x squared, and you can simplify that if you wanted to, or write it in standard form, but that's our answer. Okay. Next we'd have subtraction. So f minus g of x is how we'd write it. And order does matter with subtraction, so in this case it'd be f of x minus g of x, which for the sake of this example, it's going to be 2x plus 1 minus, and then I would always put the g of x in parentheses here. Obviously, we don't necessarily need them, but yeah, makes it a little nicer. So if you wanted to, you could say 2x plus 1 minus x squared, and then there's your answer for the subtraction. Multiplication. We have where you just multiply the two together. So it's going to be f of x times g of x. Since we're doing multiplication, I would just put them right in parentheses. So 2x plus 1 multiplied by x squared. Well, since it's one term times 2, we have to do the distribution property. So 2x cubed plus x squared would be our final answer. Alright, then one that we don't see too often in this class at least is division, but I'll show it anyways. So it'd be f over g of x, and we'd have to do the qualification where g can't equal 0, but we're going to skip that for now. This is just going to be f of x over g of x, which in this case is going to be 2x plus 1 all over x squared, and we can't simplify that, so it stays that. All right, so those are your basic operations with functions, but since functions are functions where we take something and substitute it in, there's actually another operation we have, which is called the composite function or composition, depending on how it's worded, and it's an open circle. This is also sometimes written this way. I actually prefer it this way to that I'm writing now because I feel like it makes more sense. Right? So this is function notation. So I'm substituting x in for g. Whatever I get there, I'm substituting in for f. So we're still using the same 2. I know g of x is x squared. So I would end up with getting f of x squared. Function notation tells me to substitute that in to the function. Well, the function was 2x squared, but now I'm substituting x squared plus 1, and then I could simplify it, but there's not really much simplifying to do. Okay. So in this one, the order does matter. So just to see it, I'm going to do g of f of x, so you guys can see this one with the same two functions. So here f of x is 2x plus 1, and I'm substituting it in for g of x. G of x was x squared, so it's going to be 2x plus 1, because that's what x was, and I'm squaring it. And I'm going to leave it like that. I don't have to multiply it out. Okay. If there's numbers in, you just start with the innermost. So just to see an example, if we had f of g of, let's say, 3, we're going to start with g of 3 first. So g of 3 is 3 squared, which is 9. Substitute that in, so we get f of 9, which is 2 times 9 plus 1, which equals 18 plus 1. So this would equal 19. Okay? So that is the composition of two functions. And technically you can compose multiple functions, more than just two. So you could have like h of f of g of 3. Start with the inside, figure out what it is, substitute into the next level, substitute into the next level until you're done. Okay? So yeah, thanks for watching and have a great day.